Welcome to Chapter 8. So I decided to go ahead and skip through the rest of Chapter 7 as I didn't find those topics as important for the rest of your math career in high school as I did for Chapter 8 and Chapter 9 material. So I want to focus on this because we only have another 3 weeks to go and then we are done with the school year. So my plans are to get through the majority of Chapter 8. We will probably skip the last section, and then we'll move into Chapter 9, and that will likely take us to the end of the school year. All right, here we go. 8.1, inequalities. So what is an inequality? An inequality is a comparison of expressions using one of the four inequality symbols, either this one, and I'm going to have to make a couple of modifications to these last two. I need to make these into these symbols. So hopefully these are starting to ring a bell. So do you know what these symbols are named? They actually, all four of these have names. What do you think this one is? It's a less than. Less than. So that makes this one greater than. Well, this one has a less than symbol, so we call this one less than, or the line underneath it here, the line segment underneath it means equal to, so that's an equal sign. So this is less than or equal to, one or the other. And then this symbol is a greater than or equal to. All right, the way that I personally remember these signs is I read left to right. So as I'm reading this left to right, I'd first get to the smallest piece and then the largest piece. Since I got to the smallest piece first, that's a less than. The other one is a greater than because I get to the larger piece first. That's just my own personal way of remembering it. The way that they teach this back in middle school, maybe even grade school, is they'd say, oh, make a true statement, and the symbol eats the bigger number. So we'd say that 2 is smaller than 3 because it's wanting to eat the bigger number. 2 is less than 3. Or we could put it the other way and say 3 is greater than 2. So you could remember it that way as well. To each their own. All right. So the first example says graph each of these inequalities. Let's graph them. So if we're going to graph x is greater than 5, I'm going to need to put that boundary point at 5. I'm comparing some unknown to 5. I'm going to put the boundary right in the middle. The number line gets bigger as you go to the right. So 4, 5, 6. My boundary is at 5. So I'm going to put an open point at 5. Now the question is, if I were to plug 5 into this inequality, is 5 greater than 5? Is 5 greater than itself? And the answer to that is no, this is a false statement. 5 is not greater than 5, so I don't want to shade that point in. If I shade that in, I'm saying it's a solution because we always shade the solutions. So this one is an open point because it's not greater than itself. If I were to plug in 6, is 6 greater than 5? Well, yeah, that's true. So I want to shade 6. Well, anything to the right of 5 is going to be greater than 5. So I want to shade all of the values to the right of 5. And we do that just by drawing a shaded arrow, just like this. So we're shading our solutions. The arrow means everything to the right is greater than 5. If I were to plug in a 4, 4 is not greater than 5, so I wouldn't want to shade that one. So I know I'd have to shade on the right-hand side. On part B here, x is less than 12. So again, I'm going to put my boundary right in the middle. 11, 12, 13, number line increases left to right. I'm going to put an open point at 12, and then I'm going to ask myself, if I plug in 12 into my inequality, is this true? Well, 12 is not less than 12, but remember this is a less than or equal to. The key word there is or. One or the other. If either of those are true, then it is true. So it's not less than, but it is equal to. So 12 is less than or equal to 12. This is true. So I shade that point by filling in the 12 to say, yep, that's a solution right here. All right, what other solutions do we have? Well, there's either infinitely many solutions over on the left-hand side or on the right-hand side of 12. We have to figure out which side has our solutions. If I plug in an 11, is 11 less than or equal to 12? Yes. So I need to shade the side with 11. I need to draw my arrow going to the left. All these values to the left are less than or equal to 12. All to the left, they're less than, and on this point, it's equal to. To the right, these are not less than or equal to 12. All right, this jump from example 1 to example 3, I accidentally combined these two and I didn't change my numbers. Give me just 1 second to change these up. There we go. All right, so moving on here, example number 2, write an inequality for the given graph and then in words describe the values of x that make it true. Well, for this one, this is a filled in boundary point. Since it is filled in, a filled in boundary, we will need an equal to. So one of the symbols with an equal to, whether it's a less than or equal to or greater than or equal to, but because this is filled in, we will need one of those with the equal to. All right, so let's say all of the solutions, all these shaded points over here, those are what we're going to call x. X represents our solutions. So our solutions are all to the right side of 7. That means they're greater than 7. But again, it's a filled in boundary, so I need to say greater than or equal to 7. So there's my inequality. And then the second part says, write in words or describe in words all the values that make the inequality true. Well, all values greater than or equal to 7 make the inequality true. And that's the second part of that question. Example number 3, same stuff, but a different graph here. This one does not have a filled in boundary point, so this is not going to be equal to. This is an open point, so we will not have an equal to, so no equal to. So either less than or greater than, no equal to because it's not filled in. Well, we're shading to the left of -5, so we're going to say that x is less than -5. That's my inequality. And then describe in words the values of x that make the inequality true. It's very similar to what I put here. So this one's going to be all values less than -5 make the inequality true. Example number 4, this one says, tell whether the given value is a solution to this inequality. So notice the semicolon here. I set it up the same way as you're going to see in your assignment in the textbook. With a semicolon, this is the value they're talking about. If I plug in -1 for m into this inequality, does it give me a true statement? If it does, then it's a solution to the inequality. So we need to break this off here. We're going to plug in -1 for m, and we're going to see if we get a true statement. So is this true? 5 times -1 is -5. Just make sure you follow the order of operations. So multiply before you subtract. -5 minus 2 is -7. Is -7 less than itself? The answer to that is no. If there was an equal here, an equal to, then we would be okay. Then it would be a true statement. But because there is not, this is a false statement. So that tells me that m equals -1 is not a solution to the inequality. 5m minus 2 is less than -7. There's my answer. All right, example number 5. It says, in order to try out for a lead in a certain musical, you must be at most 14 years old. At most 14. So now we're going to start introducing some different vocabulary that represents inequality symbols. This one says you must be at most 14 years old. Write and graph an inequality for this scenario. Well, I used my little example of a coffee cup. I've got a coffee cup that says you can have at most 12 ounces. Well, obviously, they put more than 12 ounces in this coffee cup because it's overflowing. So at most means that much or less. So at most 14 years old would mean 14 or younger. So we're going to say x is less than or equal to 14. That's my inequality. And then it says we must also graph this. So again, I'm going to put my boundary right in the middle. I start with an open point, but because this has an equal to, I know I need to fill this in. And then I need the numbers that are smaller than 14, and that's to the left. You could plug in 13, and 13 is less than or equal to 14, so that's a true statement, so I need to shade 13. You could plug in 15 and get a false statement and then know that you don't shade that side, so you need to shade on the other side as well. Either way, you could justify that you have to shade on the left. All right, on this example number 6, it says write the inequality corresponding to this sentence and then graph it. So the same thing as the last one. If you have been to the fair or to Bay Beach in Green Bay, really any amusement park, you've probably seen a sign like this where it says you must be at least this tall to ride the ride. So if it says you must be at least this tall, well, obviously you can be taller than that, but you can't be shorter than that. You could be exactly that height, so if it just barely touches your head, you are good to go. You can ride the ride. So you can be that height or more. So what this says is a number x is at least 5, but that means you could be 5 or more. So the inequality is x is greater than or equal to 5. All right, so let's graph this one. So again, putting my boundary right in the middle here at 5, I've got 4, 5, 6. Putting an open point, but then thinking if I plug in 5, 5 is greater than or equal to 5. It's equal to, so it is filled in because that's a solution to this inequality. And then I need the numbers that are greater than 5. Those are to the right of 5, so I need to shade to the right. I don't know what just happened there. That's good enough. There we go. All right. Example number 7, we just have one more to go. This is it right here. So example number 7, you've seen and heard this plenty, I'm sure. No more than 10 people. We had that going on for a while. So it says write the inequality corresponding to this sentence. The sum means addition. So we are adding. It's a result when you add. So we're adding. We're taking the sum. We're adding a number. It just says a number. So let's call the number that we don't know a variable like x. The sum of x for some number and 4. So we're going to add x and 4. So the sum of x and 4, so x plus 4, the sum of x and 4 is no more than 7. Well, no more than means fewer than. But if it says no more than 10 people, could you have exactly 10 people? Well, yes, so it doesn't just mean fewer than, it's less than or equal to. No more than 10 people means less than or equal to 10 people. So this says no more than 7. You could be less than or equal to 7. All right, we need to write the inequality and then graph it. Well, we can't graph this unless we first solve it. So what we're going to be getting into in the next section is solving inequalities using addition or subtraction. So on this one, I'm just going to give it to you. We need to subtract 4 from both sides of the inequality. It's just like solving an equation. We're going to talk more about this in the next section. We get x by itself. We have less than or equal to 7 minus 4 is 3. So there's my inequality. And then I need to graph this. So I'm going to put my boundary right in the middle. 2, 3, 4. Draw an open point at the boundary at 3. It is equal to, so I need to shade in at 3. If I were to plug in 3, 3 is less than or equal to 3. And the numbers that are less than 3 are to the left of 3, so I'm going to shade over to the left here. And there we go. All right, so your homework is page 316 all, and I do want to go through some of those with you. So going to online textbook here, page 316. Here we go. All right, page 316, you have to do all of these, which is a total of 21 questions. All right, so number 1 says, would an open circle or a closed circle be used in the graph of this inequality? So ultimately, if there's no equal to, you need an open circle. If there wasn't equal to, you would need a closed circle. So that's really the answer to number 1. So I would say that this should have an open circle because there is no equal to. Number 2, which is different, right? Both inequalities. I don't like the way that they explain this. Ultimately, which of these is different? Well, w is greater than or equal to -7. Hang on, let me open this in a different page here so I can write on this. Okay, so on the first one, it says W is greater than or equal to negative 7. So W is greater than or equal to negative 7. That's what that would look like. W is no more than negative 7. If you're not more than, you have two other options. You could be less than or equal to. So this is W is less than or equal to negative 7. W is at least negative 7. Remember, you must be at least this tall to ride this ride. You must be greater than or equal to negative 7. And W is no less than negative 7. If you're not less than negative 7, you could be greater than or equal to negative 7. So which one of these is different? Well, this one right here, it's got a less than or equal to negative 7. So I don't write, I don't like the way that they worded this. Ultimately, they're saying write both inequalities. You could write it this way, or you could write it as a word, as a sentence, but this one is the one that's different. So I would just write down W is no more than negative 7. All right, number 3, I want you to think about that and try to explain your answer. For 4 and 5, write the inequality for the graph. So I'll go through number 4. So on this one, it's a filled-in boundary, so I'm going to use X. I'm shading to the right, so that's greater than. All these numbers are greater than 9, so greater than. But because it's filled in, it needs to also be equal to. So X is greater than or equal to, shaded to the right and filled in at the boundary, greater than or equal to. This number right here at the boundary is 9. Then it says describe in words all the values of X that make this inequality true. So I would say all values greater than or equal to 9 make it true. If I had more room, I'd probably say instead of it, I'd probably say make the inequality true. All right, I'll leave number 5 up to you. Numbers 6 through 9, it says write the word sentence as an inequality. So remember, if it just says, oh, these actually tell you what variable to use, a number X, a number B. So here it says a number X is no less than. If you're not less than, what other two options do you have? If you're not less than, you're greater than or equal to. So X is greater than or equal to negative 4. That's all you have to do on these. Just write down the inequality like that, and you're done. So I'll leave the others up to you. Let's see what else we've got here. Number 10, describe and correct the error in writing the word sentence as an inequality. It says twice the number C is at least negative 4/9. Twice the number C is 2C, so that part's good. Twice the number C, 2C, that's good. It says at least, remember, you must be at least this tall to ride this ride. You should be greater than or equal to. So that is their error. The negative 4/9, that's okay. Their error is that this inequality symbol is the incorrect way. So you just need to write down, they should have put a greater than or equal to, because it says at least. And I already corrected it on mine here, but that's what you should write down to describe that they should have put a greater than or equal to symbol because it says at least. All right, the next set here, I did one just like this in the notes. It says tell whether the given value is a solution. So pay attention to where the semicolon is. So right here, we're going to just break this off. S equals 4. We're trying to see if 4 is a solution. So what we're going to do is plug in 4 for S. And we get 4 plus 6 is less than or equal to 12. And we just want to see, is that true? Is 10, 4 plus 6 is 10. Is 10 less than or equal to 12? And yes, that's true. So is this a solution? It doesn't say you have to explain. So is this a solution to the inequality? I would say S equals 4 is a solution. If it said explain, I would say it is a solution because when you plug in 4 for S, you get a true statement. All right, I'll go through, I know some of you are going to see these fractions and start freaking out about that a little bit. That's okay. So I'll go through at least one of those with you. Fractions are messy, but we can handle them. It's all right. So let's go through number 16. That's probably the worst one with fractions. So number 16, we have 1/6 is P. We're going to plug that in for P here. We have 1/12 minus 1/6 is less than 1/3. Well, notice all of these have different denominators. They're going to be very hard to combine together and to compare to one another. So what I recommend on this one is try to get common denominators right away. Multiply the 1/6 by some value. Well, ultimately multiply it by a special kind of 1 to make this in terms of twelfths. So 6 times what gives you a 12? Well, 6 times 2. So I'm going to multiply this by 2/2. That will turn this into twelfths. Well, this isn't twelfths yet, so multiply by a special kind of 1, that will turn it into a 12. So 3 times what gives me a 12? Well, 3 times 4, so multiply by 4 over 4. So you're ultimately just multiplying by a 1 and a 1, because anything over itself equals 1. So you're just multiplying each of these by a 1. And it changes the way it looks, but it doesn't change its value. 1/6 is 2/12. So this becomes 1/12 minus, multiply straight across, 2. 1 times 2 is 2. 6 times 2 is 12. So 2/12 is less than, straight across, we get 1 times 4 is 4. 3 times 4 is 12. 1 minus 2, 1/12 minus 2/12 is negative 1/12. So I'm just going to move my work over to the right here, draw a little arrow. Negative 1/12 is less than 4/12. Is that a true statement? Well, any negative is less than any positive. So yes, this is a true statement. So I'm going to write P equals 1/6 is a solution. So that's the answer to number 16. And here's my answer to number 11. Okay? Just plug in the number and then simplify it and see if it's a true statement. All right, for 17 through 20, you have to graph on a number line. Let's look at number 20. So this one, the square root of 289. Let's see if we can actually evaluate the square root of 289. And it is 17, perfect. 289 is a perfect square. So this is, W is less than or equal to negative 17. So graph this on a number line. Okay, graph on a number line. So we draw a number line. We put negative 17 right in the middle. Remember, number line needs to get bigger as you go to the right. So what is closer to 0 is going to be bigger with the negatives. So negative 17, negative 16 would go here, and negative 18 would go here. At negative 17, I put my boundary point. Because it's equal to, I fill it in. And because it's a less than, I need the numbers that are less than negative 17, and that's to the left. There we go. So that's the answer for number 20. On these with decimals, let me just show you how you would set up these number lines. I would use, at the middle here, I'd still use my boundary value at 1.25. But then maybe I'll go up by something other than 1. You could go up by 1s, but maybe you want to go up by 0.25 or 0.5. It's up to you, as long as you keep going up or down by the same amount. So if you choose to go up by 0.25, that's fine. This could be 1.5, but then you have to go down by 0.25, so this would be 1.0, 1.0. Okay, so make sure you keep going up by the same amount or down by the same amount. You can't decide to go up by 0.25 this way and down by 1 this way. Okay, you can't do that on a number line. You have to go up or down by the same amount. So on number 19, if my middle value is 11 and 1/4, well, maybe I'll go up by fourths and make this 11 and 1/2 here, and go down by a fourth and make this just a solid 11 right there. Okay. So you have to finish out those problems, and then the last one you have to do is 21. It says, when you're driving with a learner's license, a licensed driver who is 21 years of age or older, 21 or older, must be with you. So that means greater than or equal to 21. Greater than or equal to 21. Write an inequality that represents the situation. Well, that's it. Your age must be greater than or equal to 21. Or the age of the person riding with you must be greater than or equal to 21. So that right there is actually the answer. So I went through a bunch of these with you just now. You are responsible to finish this entire page. Even the ones that I went through, you need to write those down. Okay? So you have to finish this whole page. Let me know if you have any questions. Thanks.